that is live streaming. Okay. Well, actually, is it live streaming? I think it is.
Looks like it works.
Do you see it on YouTube? Let me just check if it's on YouTube.
It said that live stream is on.
But does it show us? Let me check.
Streaming is on.
Oh, well, I can't even find the channel.
Yeah,
oh, yes, I can see.
I see everything.
Oh, no, it doesn't. Okay, so I think we're on. Yeah, we are officially live. Let me come back to this thing. Hi, Julia. So yeah, we are officially live. So just going to wait a little bit, and the wait a little bit for other people to join. What does it say? Did it say something? Live is on or something? Hi, we are actually we're on air, by the way. So by joining this call, you agreed to be on air. To be honest. Hi, Enrique. Hi, Julio. So we're on YouTube. By the way, we're on YouTube. We're live. So I think there's a delay of about 30 seconds or something. Johan. Hi, Johan.
Hello.
We are also waiting for Leo to join, I think. And then I will start. Okay. Maybe I should name this live stream somehow. Can I modify it? I don't know. I'm going to figure it out later. It's just we're learning. I'm going to be learning step by step. Otherwise, it's going to be too much. I'm just poking. Cool. Right. Okay, so Leo is here. Okay, so guys, we are live on YouTube, by the way, and this thing will be recorded. So just bear this in mind. So don't don't say the things that you don't want to be recorded forever. Okay. Anyway, so I'm going to start with showing what we're going to try to do today. So I'm going to be sharing the screen for some time. By the way, if you have any questions or any comments, just talk to me as I go. That's fine. So yeah. So you see my screen. I'm going to increase the font, by the way. Everybody could see, yeah? Is it visible?
Yes, for me, yes.
Okay, so what we're going to be looking today is this. So just to use this as an example of how we could do this change. I'm not sure if I will be able to do this whole change, but because it's not actually, I realize it's not actually trivial to do these things, because this particular change involves 3 different repositories, and I think I need to explain why we have the 3 different repositories, and how to make change in them. And I don't know how far we're going to get today, but at least it should be a good start. So this particular change is about the RPC call is to get transaction count, and usually you get people use it to obtain so-called nonce of a transaction, which you couldn't figure out from the name. And so the reason why it is this way is because in Ethereum, when you send transaction from a certain address by using a private key, each new transaction needs to have incremented nonce. So the first ever transaction has nonce 0, next one has got nonce 1, and so forth. We could perhaps see this at the if we go to either scan, for example, and we just check any let's say we just check at any random address that sent a transaction like this one. So if you look at this particular address, it has let's say 25. Well, it's actually quite a lot of transactions. But if we look at any of this, let's say the top one, it has the nonce 3896, and the one before that, it has a nonce. By the way, I think I'm going to increase this as well. This one has got a nonce. What? Actually, I'm looking at the wrong thing. Sorry, guys. So I wanted to look at the address. Yes. Okay. Sorry, I need to only look at the out addresses. So you see, that's the problem. I was actually looking at a transaction which brings the ether, so incoming calls. So I need to look outgoing calls. So when we look at nonces for a certain account, the nonces change only when there is outgoing transaction. So we looked at this before, and the nonce was, what was it? The nonce was 3896. So we expect the one that the previous outgoing transaction will have a nonce 3895. Let's check that. So that's the previous outgoing transaction, and it has a nonce. What is it? Yeah, correct. So and it goes all the way down to 0. And just to check that it starts with 0, because I'm not sure myself, go to the last page. So the first ever transaction that came out of this account, which was a long time ago, in 2018, had a nonce 0. You see? Okay, so I've got it. So essentially the nonce increments, and so why does it? Well, how is it related to this? So incidentally, the current nonce is equal to how many transaction has been sent by this address. So, for example, if the current nonce is 0, which means that the next transaction that will come out of this address will have nonce 0. 0 is also the number of transactions that has to come out of it. So that's why the people, when they call this method, they usually want to get the nonce of the account, which will be, or they can. So this method is most commonly used. So when you want to send a transaction, you need to figure out what the nonce should be. And in order to figure it out, you just call this method, it gives you the result, and that's what your next nonce should be. Anyway, and usually people call it for, so usually this method has two arguments. So, and I think in order to demonstrate this, I'm going to show you the how to reproduce it in Erigon. So this is where I run girly. So I'm just show you from the beginning what I do. So this was my girly running. So I can show you, this is the devil branch, and I can even pull the updates. Yeah, there was some updates. You see somebody pushed something in devil. So then I do make Erigon to build it, to build the latest version, and make it. Is it, by the way, is my screen visible? Is the font big enough? Or should I make it bigger?
Yeah.
Okay.
No, it's fine.
So yeah, and the command line that I use to launch Erigon on girly is this. So I use the Erigon executable, then I specify the data dir. This is, you can, by default, you don't have to specify it, but if you specify it, at least you know where to look for it, because I never know where it's going to put it by default. And then you specify the chain has to be girly. And then when you start it, it will go through all the motions, and it will start, you see, downloading the blocks. And because I only shut it down very recently, it will sync up very quickly. So, but while this is happening, the next thing I can show you is how to run the RPC daemon. So I'm going to increase the font here as well so that you can see. One sec. Okay, so yeah. So in the same directory, again, it's the same directory, but it's just a different different screen, different tab. I will call the make RPC daemon. So RPC daemon. Oh, I actually misspelled it. It's going to be daemon. By the way, you don't have to kind of spell it all. You can just do make, and it will kind of make everything. But it takes a bit of time. So the so what is this? Okay, so here you can see what happened here is that we have it in a situation where we most of the time we're looking at this line, which is basically says that we're waiting for the new header to arrive. And if we look at the either scan on girly, so not on the mainnet but on girly, so that would be girly either scan. So in here you will see that the latest block that Etherscan has seen was again, I will just increase 5,690 blah 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 512, right? And so we are already on 518. So we're kind of a bit ahead of Etherscan. Let me just see. I'm gonna refresh it again. No, the Etherscan is now caught up with us. But now we're actually on the 19 already. So we are a little bit faster than Etherscan, I suppose, if I keep refreshing here. Yeah, you didn't see the 19 yet, but we already saw it. Okay, we're already at 20. Anyway, so I'm not going to play this game, but although it's quite exciting. This is the Erigon synced up, and now we have RPC daemon here. So by default, when you run Erigon, it opens a socket, or open the socket connection on the port 9090, and it's accepting connection from RPC daemon. So it says here that it notifies RPC daemon, but actually there is no RPC daemon. So what I'm going to do now is that I'm going to run the RPC daemon and to connect it to my Erigon. So daemon, and so here I specify private API address, localhost 990. So you can also run RPC daemon in so-called shared dual mode, but by specifying data dir, the same data dir that you had with Erigon, it will be able to access the same database. But I don't need to do this at the moment. You do it for performance, but I could do it this way. So then you have to specify which APIs you want to see, and for now we only need one API, which I think by default it's available. So what we can see here, it opened up HTTP endpoint. So it means that although our Erigon is listening on the port 9090, this is how the RPC daemon connected to it. But RPC daemon itself is acting as if it was a HTTP server, and it's listening on a port 8545. We could also override it using another parameter. And you can see here, another thing you could notice is that there are currently 4 services that our RPC daemon connected to. And so remote DB, is backend, mining, and the TX pool. So when I'm starting to show you the repository, the interface repository, I will explain you what the services mean. But one thing you might want to know about the gRPC is that so we have a basically gRPC endpoint that Erigon is creating, and you can bind multiple gRPC services to a single endpoint, and that's exactly what we're doing here. We bind 4 different gRPC services to the same endpoint, and the RPC daemon is connecting to all of them. And the one which we'll be using today is this one, which is the TX pool endpoint. So okay, so that's what we do. So now we need another terminal screen to be able to issue this command that we want to be testing. So let me just do this thing again. And now I need to remember curl. Or maybe I should just paste it from somewhere. Does somebody has the curl command handy somewhere. Does anybody have a curl command? Is it, maybe I could find it in the here. Yeah, that's what Alexius is showing. Okay, so let's modify this curl command just so that we could. Okay, so this curl command will need a method, not it syncing, but it will need a method get transaction count. Okay, and it will need to go to the correct place, which is the local host and 8545. And then we need the parameters. So I remember you can actually Google this method and figure out the parameters, but I believe it takes 2 parameters. And the first parameter is going to be the address of the address that we're interested in, whose nonce we're going to be taking. And the second parameter, whether it's going to be latest or pending. So let's try latest. And so let's take the address from Gurley, some kind of address from Gurley. And you know, to make it a bit more interesting, I will use the pending transactions. So this is the, in Etherscan, you can see pending transactions. And then we're just going to pick the thing that has been there for a while. For example, this guy. So, and we will, actually, we need to pick the one, we need to look at the from destination. So, okay, let's pick this guy. So you can see this account is pretty cool because it has lots of pending transactions in which are in the pool, but we also have a transaction which has already been mined. So let's have a look. The nonce for this transaction, it's 71. Okay, so we expect that if we take this particular address, and we should get the nonce 71. Okay. Okay, let's see what happens. Okay, so what we get back is that's our result, which is 84 in hexadecimal. So usually what I do is that I go to Python and do this, 84 to 72. Okay, so that's cool because that is what we expected, because the 72 is the number of transactions that already been mined from this. Remember, because they start from 0. And if you count from 0 all the way to 71, it's going to be obviously 72. But if you look at all the pending transactions, there's about 1, 2, 3, 6, 9, 12, 14, right? And so the nonce for this one is 85. So 85 minus 14. It kind of makes sense, right? So let's check that the functionality that we want doesn't work yet, and so that's what we need to fix. So basically, if you call this method not with the latest but with pending, let's see what happens. It also returns 48, which is actually not what we expect, but this is how it works right now. So what we need to do is that we need to fix it. And so we expect that the result should be not 84, but no, sorry, not 48 hexadecimal, but let's convert. It will be 86 converted to hexadecimal. Let's use Python for this again. So let's do hex 85 or 86. 6. Yeah, it should be 56, right? Yeah, that's basically what we need to do. Any questions so far about this? No? Okay. Okay, cool. Then I will continue. So next thing we're going to do is we get out of Python here. So next thing I want to explain you why this change requires going to 3 different repositories. And what are these repositories? So basically, the repositories I'm talking about are interfaces. So this repository exists because we have actually, first of all, you can look at this picture, and it says so Turboget. We need to rename it, and actually we also need to change this picture. Maybe some of you might want to make a PR for this, because actually this picture is provided in the where was it? There is this picture uploaded somewhere. No, it's yeah. So the picture is no. Anyway, so I think you need to find this picture anyway. So gosh, sorry about that. I don't remember where this picture is, but maybe I'm just looking. Yeah, sorry, I'm looking at this. So the picture is in this file. It's draw.io, and it just needs to be rewritten. So the reason why it needs to be rewritten is because we have, I suppose, the color coding here. So what it represents, this picture, is that there's this Erigon, and it consists of multiple components, and some of these components are separate and some of them are separable. And so the core is what we sort of started with, the situation where everything was one single component, and this is how most of our implementation currently work. So the first thing we did, we took out this API service, which we also call the daemon or IPC daemon. And you can see here there's this notation where you have these little fists and the palms holding the fists. So basically, when you have a hand, it means that it's opening, it's listening to the connection and exposing certain service, and the fist is basically like something trying to connect. And so here's the KV and East backend. So KV is essentially remote database access, and East backend is some auxiliary functions. Now, so the daemon can only run in a separate process. You cannot run it within the core. And that's the kind of the only component which has to do this. And obviously the JSON RPC is served by daemon. So when I showed you in the command line what happened, I actually started up the core with lots of other things inside it. And then I started up the daemon, and I was connecting as a little user here through the JSON RPC, and I got my results. But the data that it got came all the way from the core. So some of it from the database, and then just pushed through the KV interface. And the daemon basically did all the processing into JSON, from JSON and back. But what we're interested in this particular issue is that we need to go all the way. We reach out to the transaction pool, and in fact, this picture is also incorrect because there's another thing here where a daemon connects to a transaction pool, which is missing. And also, I think we put the green stuff here is that for the things that we already separated, but actually we already separated the sentry and the transaction pool. They should be green on this picture, and there should be more TX pools. So if somebody wants to try to work with this picture and make a PR with the uploaded version, that would be great. Anyway, so but this particular repository is describing those interfaces, those connection points, and because we're using gRPC, we're describing them in the protobuf format, and that's why. So the things that we're interested in today is the TX pool interfaces, so this is how they're described. So usually you have what you need to look at is the service. So that's a service TX pool, and that's actually corresponding to this. So if I look at my RPC daemon screen, where was it? You see this. This is actually corresponding to that service that I'm showing you in the repo. And then you could probably spot that there was the mining here. And so the mining service, we're not going to look at it today, but the mining service is that, and it corresponds to the line here. And so that then the KV that you saw on the diagram is actually this, and the East backend is this. So for example, East backend allows you to get the version of the server or something like this. So anyway, today we're going to be looking at this, and the corresponding proto file is here. Right. And so the reason why this is in a different repository is because you might be aware that Erigon is not the only implementation we're developing. We're also developing Silkworm, which is C++ implementation, and Akula, which is the Rust implementation. And also we have another RPC daemon implementation in C++ called Silk RPC. And all these projects, they require these proto files. And because they're also kind of different, using different languages, so that's why we try to keep this repository sort of language agnostic, but we do have some Rust code there, which helps us, I suppose, to check. So this code, I think it's what's quite useful to verify that the proto files are actually correct, because when you try to do the okay, so the proto file. So when you try to make a pull request and the so I'll show you. Yeah. So the one of the checks here that what was the checks? Yeah. So these checks. Yeah. So basically, like the Rust. I think. I look at the details, it tries to, I believe, maybe Artyom can correct me, it tries to create the bindings for Rust, and this is one of the ways to check that your proto files are actually correct. Is it right, Artyom?
Yes, exactly, because as part of the bindings compilation, it actually compiles the proto files themselves. So if the proto files are not correct, the Rust CI will fail.
Right. Yeah. Okay. So that's kind of useful. So, but otherwise, this repository is supposed to be language agnostic. And another thing about it is that you probably saw the. In fact, yeah, you probably saw the different ways that repositories, especially the Go repositories, can be related to each other. For example, there is these modules where you can, one repository uses the modules from the other one, or there's a Git what's called submodules, or there's another thing which is called Git subtree. So it's up to the other repository that uses interfaces how exactly they use it, either through submodules or through subtrees. For example, we use this as the subtree from Erigon lib. So that's why I'm going to take you to the Erigon lib now. So the Erigon lib, the reason why it's separate from Erigon is something to do with the license of the code. As you may know, that Erigon itself is derived from Go Ethereum, and therefore it has to have, at least for the code that we inherited, it has to have a GPL license. But we wanted to create something with Apache license, and so we started the kind of the new development. We're putting a lot of it in Erigon lib, and one of the things that we're putting here is actually Go bindings. So we are bringing in these interfaces here using the Git subtree. But the thing about the Git subtree, it's different from submodules. So if you look at the submodules, I can show you. Like if you're, for example, in Erigon repository, you could see this is a submodule, right? It shows it like that. And there's probably another one. Yeah, there's another submodule inside the test here. Right. And submodules are kind of interesting, yeah, because they basically reference in the other repositories at a certain revision. And but the subtrees are kind of, they don't look like this, so you can't tell really whether this is submodule or not. And this has a pros and cons, and we're not going to go into this. But what I'm telling you that this Erigon lib is actually taken in the interfaces as a submodule, and it's a bit tricky to update it. And that's basically how we update it, and we're probably going to do it today if we have time. But anyway, so that's basically exact copy of the whatever version of the interface repo we put here. Okay, so and then the reason, as I said, the reason Erigon lib exists because we're putting here the code which has Apache 2 license, and in particular, we have rewritten. It was mostly Alexei who rewritten this transaction pool from scratch recently. I mean, I wrote the design, but he did pretty much most of the implementation. And so that's why the functionality that we're going to be changing is here in Erigon lib. Well, the other reason why we'll be touching is, so we will first change the interfaces repo, then we will need to rebuild the bindings, Go bindings, to generate the gRPC code for the changed interface, and then we will actually have to go into the probably this file, and then there was something about nonces here, nonce. And in fact, I think Leo has already submitted the PR. Let's have a look at this PR, which does some of this. Okay, so what did he do here? So yeah, so I think he submitted, Leo, you already submitted the changes in the regenerated bindings, right?
Yes, from the proto files to generate the local file.
Yes, good. So that was, that will be kind of save us some time. So what Leo did, he changed the txpool proto file, and what he did is that he added this new function, get transaction count, so in the same service. So that means, in our terms, that when the RPC daemon connects to Erigon and it uses the txpool service, now, after it's all in, it will be able to not just ask for a version or, add a new transaction or doing like getting all the transaction or something. It will also be able to ask for a transaction count for a specific transaction. And if we look at the thing about this is actually there is a bit of a mistake here. So we don't really specify which address we are interested in, right? So this will require a little bit of change, because when we asking for the transaction count, we will need to specify the address. So where was I doing my request? You see, when I do the request, I've specified for which address I'm doing it. So, and then of course, when RPC daemon is asking about it, it also needs to have the address. So basically, we need to add the address here. And as a reply, yeah, we've got a nonce. But there was also another interesting thing here. So, and this is the implementation, right? Okay. Okay. Oh yeah, so this is it. So that's the implementation. So we have already in the txpool pool.go, I think Alexei has already added a couple of things we can utilize, and these are the first thing we can use is that there's a senders object or whatever it is, I think of the type senders batch, where there's a function ID, and what it does is if you give it the address as a string, it gives you the ID. I think the ID is some kind of uint64. And then using this ID, then you can call another function, which is nonce. You see in Go, this is unexported, so it's only local to this particular type. And so it gives you the nonce. And another thing it does, it's if, for example, if we look at here, right? So here we found specifically the address that does have anything in the pool, but we might also take an address which doesn't have anything in the pool. So it hasn't sent any transactions for a long time, and therefore there would be nothing in a pool, in a transaction pool related to that. Okay, and so that's why when we are calling the function senders, it gives us two parts of the result. So first not this one. So this one actually gives us two things, because if the certain address is not found, then OK will be false. And I think we also need to handle this situation here. I think it's not handled, but also the nonce. Yeah. So basically, yeah, if it's not, if the pool doesn't know anything about this address, we just have to return it false. So, and if it does have anything, if it did find the ID, then we can get the nonce. So that's why this particular method has two return values. But when we use it here, we get transaction count. Okay, so that's the strange bit about it. Yeah, so you see what we need to do here. There is a discrepancy between, you know, okay, we need to see what our generator. So we're going to be looking at the code which is generated by the gRPC generator. Okay, and so the way that gRPC bindings generated this function for us, and this is what we will have to obey because it generated the interface. This function needs to have this particular signature, right? And you can see that it's different from what we currently have. So that's one thing we need to rectify. So this is the signature we currently have, but the signature that we need to get to is, where was it? Is this, right? Okay. Okay, so let's start. Any questions about this before we go on?
Sorry, I kind of like blacked out, so I don't know if I missed a lot.
Okay. Questions? Is everything is fine?
Yeah,
everything is understood. Okay. Well, let's go to the ID then. I'm going to launch the ID. Okay. So I'm going to cheat a little bit. So instead of going into the so with my ID, I need to also increase the font. Okay. Right. So because we use because in Erigon lib we use interfaces as the git sub tree, I can actually cheat, and instead of going first into the interfaces and do changes there, I actually can try to modify it right here. So I'm going to actually, let me take this command and I will just put it into this window. Okay, so let's check it again. Cool, it works. Right, because I actually had the Erigon lib already here. So, but first, before I do anything, this is my Erigon lib, by the way. So I'm gonna check which branch I want. See, I'm in the wrong branch. I'm in the aggregator branch, which is something that I'm working on. But let me check. In the one thing you need to notice that in each repository they have a different default branches. For example, in Erigon lib has a main branch is the default, and if you land into like Erigon, you can see the default branch is devil, and if you land into interfaces, I believe that will be master. So it's three different things. Anyway, so I need to first go into the default branch, which is main. Okay, main. I'm going to pull the latest thing from main. Okay, sure. And so then I need to kind of branch off from the main. So what I do is that git checkout -b, and let's say that whatever, tx pool pending. Okay, so that's going to be my branch. And so I will first start modifying the interfaces. And so what I will do is open the, I'm going to cheat, as I said. I'm going to go straight into interfaces here to txpool and txpool prolo. And I'm also, the second way I'm going to cheat is I'm going to look again at Leo's PR, and I probably take something from there because I'm a bit lazy like that. So I'm going to take these two things here, right? Where is it? Okay, and I'm going to put them, let's say, here. Cool. Right? But I do know that, first of all, we need to have an address. And that's the first thing we need to fix. And how do we get address? Well, we have addresses in some other files. Let me check, because I'm kind of not remembering what we are. So addresses must be, as far as I remember, they were in here. Okay. Yes, addresses. Okay, so basically we have this type, which I think Artem introduced, H160, which simply means that it's 160-bit value. And if you do the math, you could figure out that 160
It's an address.
Yeah, so it's basically
20
bytes. Yeah. Okay, so that's why I'm putting it here. And another thing we need to modify, as we said, that we also want to to be able to say that we haven't found this address. So just do we have a bool in protobuf? Does anybody remember? I don't remember. We just say bool found equals 1 and nonce equals 2. I have no idea if we have bools. Let's check. Okay, it's a good thing to check, right? And so the next thing we need to do is to just take that thing and just plant it here as another function. Cool. Unfortunately, it doesn't help me with formatting here. Anyway, so that's what we did. Okay, cool. Let's check if it works. So what we need to do in Erigon lib, there's a special helper thing, which is called make grpc. And if we run it, magically, yeah, it thinks it works. And so now we actually can see what it did. So I usually use git diff to see what it did. And so we just can skip this thing. Transaction count reply. Cool. So, cool. So what we're looking at is is this thing, get transaction count. Okay. So that's the function that we will have to implement. And it's function of the txpool client. Okay, so let's see how we implementing these things. Okay, so again, I'm gonna use the Leo's code to guide me. So I think I need to open the file txpool grpc server. Because actually, if I don't do that, if I just do make right now, I think it's not gonna build, right? Oh, we did build. Well, that's weird. Anyway. So I'm going to go to txpool grpc server.go. Okay, so txpool grpc server.go. Okay. And so what do I see here? Well, I see the grpc server, which I think is the thing that implements all these things. Yeah. So I could see this is it's grpc kind of, looks like grpc types. And this and that and that and that. Okay, cool. So, okay. Stream. I think we should be about here. Okay. And what I'm going to do is that I'm going to take the signature that I'm supposed to implement from the Go interfaces where it's generated them. Okay, so the signature should be here. Okay, so that's what we need to implement. So we just get the signature. Okay, we get to the implement. So we're going to create the implementation of this stuff. All right. Okay, so obviously we have to fix the package names here. Okay, right. So, okay, so now for now, what does it return? It returns these two things. Okay, so let's check what I usually do. Let's just put some dummy stuff in here. and see if it actually compiles. Okay, with the dummy stuff, because it might not. Oh, I'm becoming a bit suspicious, you know, that it actually compiles anything at all. Let's put some really strange stuff in here, because I'm a bit suspicious that it does anything. Oh no, cool. What? Oh, what's this? Undeclared name. Yeah, so okay, fine. So it actually is compiling this stuff. Now, so then the next thing we need to do again is to look at what is happening here. So now first we use again, thanks to Leo for doing the beginning of this. So we need to use this function, which is converting our H100 type into the slice of bytes, right, that we're going to be using later. And so here, let's just paste it, and then we'll figure out where these things are going to come from. So Go interfaces is the package. Is actually placed here. I'll show you. So it's just a utility. So the Go interfaces contains the things that a gRPC generator is generating, but also it has a type utils, which is not generated code, which is something that we've written. And it has these helpers to convert the gRPC generated types into what we are used to, like this is the address and so forth, and then you can convert the other way. If you have an address, then you just send it over, and that's actually what we're going to be using in the transaction pool, or sorry, in RPC daemon. Because the RPC daemon will need to, given the address, it will have to convert it into the gRPC thing and then send it over, and then the Erigon will have to take this and convert it back to the address. Okay, fine, where we were. Okay, right, we were here. So, but where's the address? Okay, the address is inside the in, okay, inside this in request. But let's check what is this in request is. So it should be in this file. So usually when there's a generated files, so the ones which the name ends with a pb.go are the types, where the generated types, and the one which is underscore grpc.pb.go is where their services are. So that's why I know that if I need to look at the type, I need to go to the pb.go. If I need to look at the service, I need to go to the grpc pb.go. So what I'm looking at is this type. So let's just find it straight away. Okay, so that's the type. And we can see that inside this type, there is this field called address, and of the types H160. Cool. So I know how to get to it. So I'm going to do in.address, right? And now what it returns is the array of 20 bytes. Okay, array of 20 bytes. And so what does this thing do? It says get nonce from address, blah, blah, blah. And get nonce from address, it's from the pool. Okay, so we might just cheat a little bit again and do this straight away. Oh, but okay, so that's the interesting bit about it. Oh, okay. So I think, Leo, when you were writing this function, you were assuming that you have somehow the reference to the transaction pool. But in the function that I'm working with, there is no such thing. So we need to look inside the gRPC server to see if if we can get hold of the transaction pool from there. And actually we can, right? So yeah, that's pool. So we're going to be using pool, which is inside gRPC server. Okay, where is it? Okay, so this is where we are. Okay, so we can get to the pool by using s.txpool. Right? And then the first thing we're going to do with this pool is we're going to try to look at the senders. So here, this is the senders, dot senders, and then from the dot senders, we use the ID function. Okay, so we just do that senders, and then senders ID function. Okay, so and the ID function is returning us the two things, ID and OK. OK basically true if there's something found. So sender ID found, right? So okay. So it doesn't. It tells me that it can't find the senders, but let's check that. TXPool. Oh, because TXPool is the interface. Oh, that's another interesting thing. Okay, cool. So now I understand why you did this. Okay. Right. So yeah, the problem I have is that TXPool is actually an interface, and the thing that I need is contained inside. Where is it? Is inside this file pool.go. So you see this thing has got senders. Senders, but it is a private, not really private. There's no such thing as private. Anyway, so this huge type TXPool, it's got lots of stuff in it, including the one we need, the senders, but we can't use it directly because the gRPC server only works through this interface. So what we'll have to do, we have to do something like Leo did here, but in a slightly different form. Obviously, we can't rely on this in an interface, maybe. So we're gonna just add this thing into the interface in some form. Let's check. Right, so the interface will now have a function, let's say nonce. I believe that it's supposed the Go convention is not to have get. It's for the getters, and obviously we don't need to do to pass the B because it's already part of the pool. So it's the internal detail of the pool. Okay, we could pass address as an array, but that may mean that it will be copied over. So I could say this instead, slice. I'm not sure which is better, but in some cases we use addresses in some slices. Okay, let's check it. Let's do the address input by. Okay, so I think that should work for now. So now, because we are working through this interface here in our implementation, we're just gonna use the interface. And actually, in fact, it will just give us the nonce straight away. Nonce from address, and we don't need to do string conversion. We just give it whatever we have is the address. So for simplicity, I'll just leave it like that. Okay, so and now it tells us that it's not used. So we're gonna wrap it into the transaction count reply. Let's look at what the transaction count reply should look like. Okay, all right, let me just find it here. So yes, transaction found reply, these are the internal stuff that we don't need to check, but we basically need to provide two things, one bool, one int64, one code found, one code nonce. Pretty easy, right? Easy peasy. So we need to do type constructor. So just copy this. Okay, so nonce equals nonce, found. Okay, should work, right? Now, oh, in pool. Whatever. Okay, so what is it? It's not happy about this thing. Anyway, I think it's confused a bit. So, but one thing is missing. We haven't actually implemented the. So, if I actually try to compile it, it will probably tell us that I haven't implemented that function. Oh, very weird. There's something wrong with this compilation because I don't expect this to work at all. Okay, so we need to implement this anyway in a transaction pool. Where was it? Here. So that's our TX pool gigantic class. Let's just put it here. Unlocked, discard. Okay, let's just put it here. All right, and then what I'm going to do, because we are now having P as a pool, right? Now I can do these things. So we do P dot senders. Take a string. Okay, fine. Found. Okay, and wait. If not found, return 0, false. Okay, and then if it's found in the sender's ID, I will return this. So because basically here there's no point calling the nonce because it won't give us the good result. So if there's not found, then we don't gonna call the nonce at all. So that's the difference between what I'm doing and what was here. Because here basically the problem is that even if OK is false, it will still try to do the nonce, and I'm not sure what nonce is going to do if ID is not found. It's probably going to give you 0 or something potentially, but I'm not sure. Okay, I think it's, is it P? Or no, it's not P. It's the senders. Right, again. No. By sender and nonce. I think there's such a thing called by sender and nonce. By sender and nonce. Okay. Another thing we need to think about. Okay, let me check. Again, I'm a little bit here. I'm a little bit cheating here because I am familiar with this code a little bit, obviously. But sender and nonce. Okay, it's called all. Sorry. So all is the thing which has all the transactions in. So it's going to be like this: p all nonce, sender ID, and true. Okay. I'm just curious. What does the nonce do if it's not found? Okay, it returns 0. All right, cool. So yeah, nonce basically if it's not found, this is the B3 search. If it's not found, then there's nothing. There will be never this assignment, and the nonce will be 0. So yeah, that's why we need to know whether it was found or not. Okay, so that's it. Now the other thing I need to check is the synchronization, because some of these things I need to check what we usually do with the. So I think the convention is that if you have some unexported method, they usually don't do synchronization. But if you have exported methods, that often they need to do some mutexes. And I'm trying to find, for example, here, right? So yeah, this is for example, this particular function, which I believe the best one is the part of the interface, right? No, it's not. So let me just see if I use count content, for example. If I see that count content is just locking, yeah. So you see the count content, for example, does the read locking, which means we probably should as well. Because we don't want to read. here. We don't want to read the corrupted data. So, but this is only read lock. So because we're not modifying anything. So with the read write lock, if you modify something, you do kind of this and this. But if you do just reading, you do R and R lock and R and lock. Okay. So I think let me just try to compile this stuff. Well, okay, I'm not sure if this is actually working, but anyway. Any questions so far? Maybe I'm just gonna get out of the screen share for a sec and just a bit of a break because I've been going for a bit. Okay, yeah, and I'm gonna close my Discord. Any questions so far? I'm just gonna want to have a little break, and we've been going for basically about an hour. I don't know whether we should continue or do you want to continue or do you want to have a break and they finish it another time?
What are the... I think we can continue.
Okay. Okay. What about the live stream? Is live stream still going? Let's check. I think it's still going. Right. Cool. All right, then let's continue. I think we're getting somewhere. I've just closed Discord so that there's no messages popping up. I'm going to continue then. Right. So now, what I'm going to do the next, again, I'm going to check which branch I am on Erigon lib. Still on TX pool pending branch. So I'm going to actually push. And so the reason I'm pushing it is because I now need to refer to Erigon lib from my copy of Erigon. So now I should have a TX pool pending appearing at the Erigon lib repo. Not really. Okay, strange. Did I do something wrong? TX pool pending Erigon lib. Strange. Okay, so there is a branch. Okay, let's just. But why is it? Oh no! I chose the same name as Alex did. Gosh, how could this happen? Let me just change to something else. Somehow I managed to use exactly the same branch name as Alex. That's why it didn't show up. And that what? Okay, so why am I Alex Sharov? Why does it say I'm not Alex Sharov? I think GitHub is confused. I don't know. I haven't seen this before. What's going on? Has he hacked me? What's going on? I don't understand what's going on, to be honest, guys.
I think it makes sense for all contributors to have.
Okay. I didn't add anything to my branch. That's the reason. Okay, fine. That's why it was Alex Sharov, because there was no changes. Okay, that's stupid of me. And it wasn't that I picked the wrong name. It's just that. Okay, so now there will be something in it, and then it will show me. Yeah, that's it. So let's create a draft pull request just for whatever. Okay, and what we're really interested in is the commit number, commit hash. So I could find the commit hash, for example, here is what it's committed to. And the reason I need it is because now I'm going to go to Erigon, to my local copy of Erigon. I'm going to stop the, I think I need to stop both Erigon and transaction pool. But first, I want to keep my Erigon kind of fresh, so I'm going to stop transaction pool first. So I'm going to check which branch I'm on, which is Devil. Okay, cool. So I'm going to create my own new branch, TX pool P. Okay. That's going to be a different branch, but it's because it's in a different repo. And so what I'm going to do now, just check. Yes, I'm in TX pool P. I'm going to go use something from the Go utility to update. Okay, so I need to explain. So the way that Erigon and Erigon lib are connected is via Go modules. So it's specific to Go, and if you want to check this, you can find the go.mod file and search for Erigon lib here. Okay, here. So that's basically in the Go mod file. You usually have the list of all the Go modules that this particular project depends on, and it specifies in our case the specific version and the commit number. So what I'm looking at is actually changing that. I could do it by modifying the Go mod manually, but it's better to use the special tool for that because it actually needs to modify two files. There's another one which is called go.sum, and so to do it easier, so we want to modify just this dependency to make our local version of Erigon point to the version of Erigon lib we just created, which has got modified tx pool. So I can use some copy paste. So what I do is that I copy paste this part, go get, and then I specify the at, and then I need to specify the version of Erigon lib I want, just this one. This is this particular commit 5712. And wait, let's see what happens here. Something happens. And that's actually why we had to push it first into the, I don't know how to do it yet without pushing. So you can see that now it's updated this into the into this version. And the way that it looks in the repository, if you do git diff, you can see that it's created the diff in a Go mod file, pointing to this new version. And also it created the differences in the Go sum file, but we're kind of really interested in the Go mod file. Anyway, so if we now make Erigon, actually let's do the full make. I'm just going to show you. So if you don't want to remember, okay, you see this is what I was looking for. So now we've brought up the new gRPC server, and what we have is that our implementation of transaction pool does not have this method defined. But why? Oh, yeah, because actually, yeah, there's another complexity here. So let's open the ETH backend on the line 390. This is already Erigon repo. So ETH backend is basically this enormous file, which really should be broken up, but it basically does everything. We used to have one of these things before, which was the blockchain.go, but we managed to get rid of it, but now it's this one. So yeah, the 390, what's happening here? Okay, so yeah, the problem here is that we have this interface, which we modified, the interface takes pool server, which now has a extra function. And we're trying to assign to the variable of this interface, this particular thing. And this particular thing is probably doesn't have that function defined. And so what we need to is find out why. Okay, and then we need to find out why is this. Okay, which type is it? Okay, so it's a type of gRPC server. But where is this gRPC server coming from? Okay. Oh, it comes from Erigon lib. But we did define the function. Maybe we defined it incorrectly. Okay, I think what we did is we defined it incorrectly. Yes, let's check. If you look carefully, you will notice that this is what we had with the just gRPC call option, and then this is what we're supposed to have, which is doesn't have the call option. And I think, yeah, there's a difference between how these things defined in a client and in a server side. I think we just by mistake we implemented the client bit of it. So what we need to do, luckily it's very easy to fix. We need to go to gRPC server in our Erigon lib project, and we just remove this stuff. Okay, let's see if it works. Make. This thing is just not going to find anything. So let's check. Okay, tx pool. Fix interface or fix gRPC. Okay, so we're pushing now, and we're actually remembering again the commit. So this is the commit that we're going to be using right now. Okay, and let me bring this version again. So I'm going to remove this one and put this one in. Wait. And now we're going to have a new version after a while. Okay, look, and let's see if it works this time. Okay, it works. You see, if you use make, it's actually building not just so you can see this is the RPC daemon build, but it's also, and the first one is Erigon build, but it's also building some other stuff. And that's why if you want to just do it quickly, you can just do make Erigon or make RPC daemon. So it basically it builds. Now what happens is that let me go back to this to the picture. It's not going to work right now. So if I let's say I'm going to demonstrate it to you. So although we kind of rebuild everything, and now the transaction pool inside Erigon has the new functionality, this functionality isn't actually used. So, and I'm going to demonstrate it to you by just simply, let's see where's our RPC daemon command here. Okay, so let's restart. We're restarting the Erigon, okay, and we wait till we get. So by the way, the one thing I needed to point your attention to is this. This is the line we're looking for when we're working with the transaction pool. It periodically prints these lines where it says, okay, here's the statistics for the block, blah, blah, blah. And inside the transaction pool, we have 3 subpools, pending, base fee, and queued. And if you see zeros here, which means that there's no transactions yet that our node knows about, and we need to wait a little bit for it to populate. If you want to know what these 3 things mean, what you can do is that you go to Erigon wiki, and on the right hand side there's this transaction pool design page. And so it's, I recommend read you, if you want to know a bit more about how we did the transaction pool, you can read this. So it starts with describing what functionality do we need from it. And then we describe the transaction pool before the EIP 1559, where there were only 2 subpools, queued and pending. And then how this is still functionality. And then the changes. So we in EIP 1559, there's 3 types of pools, and there's a bit of a description here. And there's how this basically transactions go between the pools from one to another, and so forth and so forth and so forth. And yeah, there's basically, yeah. So if we want to know like what is the difference between these three pools, you can go there. But what we can see here is that where is it? Yeah, we can already see that we have some transactions in the pool, right? But if we now launch our RPC daemon and then try this thing again, it's 48, so it didn't work. Okay, so what's missing? Of course, because we didn't actually modify the RPC daemon itself and then in order to do this, I gonna do this. Okay, so we usually so the RPC daemon code is it lives in here in RPC commands, and there's the different like commands here, and the ones that we really want is you can find them with grep usually, but the one we need is the get transaction count. So in order to convert from the, you see that's the method name into the function name, how to grep it, you just drop the what we call the namespace and then just capitalize the first letter. So for example, if I didn't know that this is the file, so what I would do, I'm just going to copy this and I do my favorite grep command and I just do cmd RPC daemon, or even CMD would be enough actually. So because there's not much stuff in. So and then by the results, I get 3 results. So first result is a mention in the comment, fine. The third result is the description of the interface, and the fourth result. So the second result is what we need. Is you could actually look at it and say, oh yeah, that's the implementation of this function, and you know that you need to look at this file. So there's no magic here. You just basically use grep and find where these things are. But I knew that, and I'm going to open this file, right? Okay, where's the CMD BCD command if accounts it was, right? Okay, if accounts. So and this is what I need. Yeah, that's it. Okay, so what we have here is the if we look at this signature, and we look at how we actually invoked this method here, right? So what happens is that there is some automagical conversion in the code, which is a bit involved, which tries to, in a generic way, to convert these things into the signatures. That's why you won't need to add, when you add a new RPC method, you don't need to add like special descriptor. It sort of has this reflection-based automatic conversion, and it follows a certain convention. But in this case, it converts this address into this address, and it converts the pending or latest or whatever, or a specific block number into the value of this type. Okay, and if you don't know how to work with pending, what you can do is that you can search for pending, and obviously it's not in here, but then we use our friend grep again. Where's it? Yes, we use our friend grep to look about any examples of pending. Okay, so there's some examples here. Ooh, okay, pending. I don't actually see good examples here. Okay, let's look for latest. Maybe, yeah. Again, I'm cheating a bit because I know there is this thing called latest block number, and so that's why I'm probably need to be looking for pending like that. Yeah, if block number equals pending block number. Okay, so let's do that. So we need to handle this specific case, and we also know that if it's pending and we found something in a transaction pool, we probably don't even need to open a transaction to the database. So we're just going to do this. If block number or hash equals to I think I will have to look up this type. I don't remember what it was. Block hash, block number. Okay, so if the block number is not okay, if the block hash block number is not nil, and if it's so this is basically here I'm using the reference, and it can only dereference if it's not null. That's what I'm assuming. I might be wrong here, but so here we want to try to let's start with just printing something so that you know that we are actually handling this handle pending case blah blah blah, just to see what we hit them to the right place, and then what we're gonna do is that make RPC daemon. Okay, write it. Okay, and then we issue our request. Boom. And did we get the printout? Nope, we didn't. So let me see. We did not get the printout. That's weird. Yeah, so basically what I just proved that we never, this condition never held. Okay, which case I'm becoming a bit more curious. I'm just gonna print number hash. So there's basically there's very useful thing in Go, which is this percentage plus v, which will print you the content of a certain
sorry, let's see.
variable.
Is this supposed to be in the get code?
To see what it is.
Function?
So you see, this is one of the things I want to show you is that you know, I don't remember everything, and that's why I kind of sometimes you know, muddle through things, which is fine. That's, everybody does this. You see, I don't even get there, so must be something wrong with
Hello? Sorry, Alexei, can you hear me?
It doesn't actually hit this method at all.
Hello? Hello, can you hear me?
Okay, so oh, look. Did you see what I did? I changed the wrong method. This is it. See, that's a very...
I can hear you, Donald. It looks like Alex can hear us.
I can hear you. Yes, I can.
Good.
Yeah. But by the way, if there's any question on the way, please ask. I just realized I was changing the wrong method. That's why we didn't hit it. But now I'm changing the correct method, so I'm gonna rebuild it to the.
Sorry, I'm concerned. Can anyone hear me? Or
Sorry?
Oh, okay. I was wondering if you could hear me because I said you were changing the get code before.
Oh, you were no, I didn't hear you before. Maybe you were on mute or something. No, I couldn't hear it. It was all quiet. So, but yeah, thank you for pointing it out. I just noticed it right now. Right. So let's see if it works now. So what does it print us? Look. Okay. So first of all, we saw that it did print us something like this, and we did recognize that we're handling the pending case, right? That is good. We are on the right track, and so what we're gonna do here is that Inside this type API impl, there is already transaction pool client. And here you see, because we already generated everything, inside this client we have this function, which we're gonna just copy. It's called txpool, right? Okay, so we're going to do this api.txpool and blop. Okay, and then the reply error. Okay, cool. So we don't need this. So now we need to construct the calling argument. So obviously ctx is from here. Okay, now we need to construct the so usually I put the as the call options. I believe we just put the empty things. Or I usually like look for some kind of examples, but oh, it's an interface. Please help. grep, please help. Where's grep again? I believe it will be empty something. Yeah, empty options. Yeah, cool. The grep is to the rescue. Okay, grep is to the rescue. Where was it? Okay, so I can just put this here. No options. And then I need to generate the request. So, but my problem is that I don't actually have the proto package in here, txpool. So again, grep to the rescue, txpool proto, I think. No, nothing. Okay. Right, I'm kind of looking for something like this. So I actually was looking for something like this, but I usually call it proto too. So that's basically generated types, and the reason I need this is because it's going to be we're going to be creating the pointer to the type txproto transaction pool request, and I believe we need to convert the address to the h. So we need to do basically the reverse transformations, and I remember I was telling you the function that we need for that is in Erigon lib, and it's in where was it? Erigon lib go interfaces type utils, and that's the one which converts address to h. Yeah, that's the one. That's the one we need. So we're converting the and I think that's the only thing we need, right, for it. Oh, actually, here I need to go interfaces. I hope it will find it out. Yeah, it's figured it out. Fine. ID helps a little bit. Okay, so now here I need to say if usual Go stuff that you could probably write a million times a day. This thing, and then we need to extract the reply and convert it into this thing. So we just look at how we're doing it here. In order to do this, we need to have some kind of variable, or we might take it right from the reply. Okay, let's check the type again. The type transaction reply. So yeah, in the reply we just have the nonce as the uint 4084. Therefore we can construct the pointer to it straight away, like that, and return. So, but instead of nonce, we're gonna have reply nonce. Okay, is it nonce or is it some? Yeah, cool. Let's check if it works. It might be magical if it works. Right. What? Oh, really? Okay. Well, if you say so, I want to do that. I will do this. Oh. Okay. Fine. So I just made a mistake here. There should be tx pool, but I usually do tx pool proto here to distinguish it from other thing about tx pool. But let's do this. Okay, now it should work. And the moment of truth. 0. Great. 0.
Oh.
Okay. Okay, guys, I think I'm gonna. It is handling pending case. It got the 0, but I think it's a good moment to stop it for today, because we're really over the time. But I just want to print this reply a little bit. The somebody wanted to say something? Oh, we actually didn't check that the reply had a found or not. Okay, so I'm gonna do the last thing before I interrupt, and then we can just debug it offline or something. So I think it's enough for today. It's been almost 2 hours. There's a limit to everything. Yeah, so it did actually say found true non-zero, but I think that's the next level of debugging we have to do. I'm going to turn off the screen share right now because I think I had enough for a while. Anyway, so yeah, I think it's enough for today. Any questions or no? What does it actually is the live stream still show just me, or is it show everybody?
On my end, it shows everyone. So
yeah, to me as well.
All right. Okay. Cool. Very good. So we didn't get to the correct result, but I hope it was useful to understand a bit how to code in Erigon a little bit. What do you think, Leo? Did you get more or less understanding what these things are, the moving parts?
Actually, I have no understanding. Your explanation made the large code base seem like it was like smaller. So yeah, that's a good thing.
Right.
Yeah, but I think I have one honestly a question, but when we get other methods, let's say ETH gets something, do they all go through the same process, the same RPC daemon all the way down, or it depends on?
It depends on what they actually do, because some of the methods, they, in a very simple case, if the methods do not even need to do anything with Erigon, we used to have those where we just have some kind of stub, the stub. So something which just returns a constant or something like this. Something which you put in the code and it just gets returned, like a version. We used to have a stub for the version. In this case, you only need to change RPC daemon. But for most methods, the most methods to be useful, they need to actually go to Erigon and ask something. And if they ask something that is already provided by the interfaces. For example, a lot of times you need to extract something from the Erigon's database and process it and then represent it in some other form, like it's a JSON form. In this case, you don't have to add anything extra to the interface because the KV interface is already generic enough. It can give you access to any table in a database. It can just say, okay, you basically open a read transaction. You can say, I want to go to this table. I want to find this record. So you don't actually have to change the interface of the KV. You only need to write code inside RPC daemon. That's in most cases. This case is a bit more complicated because it doesn't actually take things from the database. It takes things from the transaction pool, which might be either inside Erigon itself, or it might be a separate, in which case you have to point RPC daemon to that separate transaction pool. And yeah, it does modify the interface because we did not have this functionality implemented before. Because this transaction pool is quite new, we didn't add all the functionality that we now need to extract information from it. Because one of the reasons why we have a transaction pool is to be able to extract stuff from it. You know, most of the things, in fact, in the software like this, most of the things we do is for somebody to extract information from it. Like because at the end of the day, it's a Ethereum client. It needs to synchronize itself with the state of the network. Either it could mean, you know, the blockchain, the current state of all the smart contracts, or it could mean the current state of the transaction pool, which is a bit more shaky to define. But anyway, like if you want to answer the question, is this transaction pending or not, or is it already mined, for example, you can get this answer by interacting with the transaction pool.
Okay.
Okay, guys, I think I'm going to finish for today. Thanks everybody for coming in, and I think we're going to get the video available on YouTube afterwards, which is great. And yeah, I don't want it to make it too long, but we could try to continue maybe in a couple of weeks' time, because I'm going to be on holiday from tomorrow.
Okay.
Cool. Very good.
Okay.
Cheers, guys. Bye-bye.
Cheers.
Bye-bye.
Thanks.
Bye.